கடுப்பாகுது எனக்கு, கடுப்பாகுது. எங்க போகுது?
Jai Jawan, Jai.
Hello, Mr. Praveen. Tell me.
Yes, sir. Sir, now session starts, sir?
Yes.
Okay, fine, sir.
3%.
Yes, sir. Last session I didn't attend, sir, but you sent record, that one also I'm not watching, sir.
Okay, okay. So you said that you have a night shift.
No, sir. No, nothing has shift, sir.
No,
Only
no,
morning shift.
no. Another fellow, Mr. Manu, he told he's night shift.
Oh, okay, fine.
So you are from which place?
I'm India, sir. India in Tamil Nadu.
Tamil Nadu. Tamil Nadu? In Tamil Nadu?
In Tamil Nadu, Tanjore district.
Tanjore. Okay. So I
Tanjore.
am from Tamil Nadu, Madurai.
Madurai. Oh, okay. Madurai which area, sir? எங்க இருக்கீங்க?
Palanganattam.
Palanganattam. Okay, fine. Palanganattam the bridge.
அதே.
அந்த bridge அந்த சைடுல இருக்கீங்களோ?
ஆமா.
ஓகே. ஓகே சார்.
நீங்க தஞ்சாவூர்?
தஞ்சாவூர் பக்கத்துல கும்பகோணம் சார். நேட்டிவ் வந்து மதுரை தான். அங்க திருமங்கலம் ரோடு டீ கல்லுப்பட்டி இங்க ஸ்டே பண்ணிருக்கேன்.
ஆமா டீ கல்லுப்பட்டி. ஓகே. நான் படிச்சது வந்து கலசலிங்கம்.
கலசலிங்கம் காலேஜ். அதையும் தாண்டி ஓகே.
கிருஷ்ணன் கோயில்.
கிருஷ்ணன் கோயில். ஓகே.
நீங்க படிச்சது?
நான் திருச்சியில படிச்சேன் சார். திருச்சியில பாவேந்தர் பாரதிதாசன் காலேஜ்.
பாவேந்தர். ஓகே. இப்ப இங்க ஒர்க் பண்றீங்க?
இப்ப இங்க தோகா மெக்னீஷியம் ஆக்சைடு ஒரு கம்பெனில ஒர்க் பண்ணிட்டு இருக்கேன் சார். இங்க நியூ இண்டஸ்ட்ரியல் ஏரியா சென்னையா.
ஓகே. Yes. Good evening, Sir Muhammad.
Yes, good evening, sir. How are you?
Fine. Okay, shall we start?
No problem.
Yes, sir. Yes, sir. We can start.
Okay.
Yes, sir. Going.
Yes, sir. So today we are discussing about the DC fundamentals. So the first day we are discussing about the DC fundamentals. In the next class we are discussing about the AC fundamentals.
Oh, fine.
So today we are discussing about these are the topics: that basic definitions, units, symbol, Ohm's law. So in the Kirchhoff's law we have a current law and voltage law.
Okay.
So based on the Kirchhoff's law, we go for that series circuit and parallel circuit.
Okay.
Then temperature coefficient, because in the Ohm's law we say that at constant temperature. So Ohm's law is applicable for the constant temperature. But in the real time, the temperature may be vary. So that's why we go for a temperature coefficient.
Okay.
Then we have go for a different theorems. So in general, we have 4 important theorems are the Thevenin's theorem, Norton's theorem, superposition theorem, and maximum power transfer theorem.
Okay.
But in our college life, we solve these theorems with both AC circuits and DC circuits.
Of course.
But here we have a objective type questions. So they didn't ask much more problems in the AC, not in the AC circuit, especially related to theorems. And we go for that star delta conversions.
Okay.
So star delta conversions, just we have the short circuits convert to delta circuit, delta to short circuit. There's a minimum risk problems. So these are the topics we discussed today. And each and every topics we have some sample questions with objective type. So we can able to know in what way they may ask the questions. So after that, I having some set of question banks, especially for this section, DC circuits. So at the end of the section, I will share the question bank to the WhatsApp group. So you go to that. So in that the question bank, the question bank having more than 100 questions. So each question having I mentioned the answers, but I didn't give the explanations. So just you work out that workout. If you not get the answers,
okay.
Mr. Riyas, tell me. So in the question bank, I mentioned the answers, but I didn't mention the explanations. So you got work out in your home. If there is needed any clarifications, please send the WhatsApp either in the group or in the personal. I will give the explanations.
Okay, sure.
Okay. So first we are discussing about the general units. So we are familiar with that terms, that is current, voltage. We are familiar with the current, voltage, power. But we didn't use the terms resistivity, conductivity. We are using the resistance, but mostly in our real life, we didn't use the resistivity, conductivity, conductance, Weber, magnetic field, magnetic flux, like this. So in the exam, there is a chances for asking the question for the units. For example, so that's why just we read this. I will share this PowerPoint to your WhatsApp. Okay. So just read the units, symbol and terms. For example, say we have a electric current. So electric current, we know the unit is ampere. We note as a capital A, not small a. We represent as capital A. Small a represents the area. So we forgot it. So we represent a capital A. Similarly, so in general, be familiar with the voltage, but we have a different terms are the voltage, electromotive force, potential difference. So that's why we have each and every terms, each and every quantity, we have some units. Okay. Just during, I will share these slides to you. So just read it. There is no need to buy it. Just one or two times you read it, we get the answer. We remember that symbols and units. Okay. So we familiar the power, it is a watts. But in the electronics, we are using the term power. So at that time we are using the term decibel milliwatts. Decibel watts. These are the terms we are using in that electronics. So in general electrical, we use the term power watts. But in the electronics, we are using the term decibel milliwatts like this. And we are familiar with the reactive power, apparent power, real power. So this power is called as a real power. The W, that is W stands for watts. This watts represent the real power. So apart from the real power, we have a reactive power and apparent power. So for the reactive power, we have a unit VAR. For apparent power, we know volt ampere VA. So capacitance denoted as C and unit is farad, represent as F. And similarly, inductance, the unit is Henry, we represent as H. But in general, the farad and Henry is a biggest unit. So usually we are using that microfarad, millifarad. So similarly, millihenry. Okay, because we are using that capacitor in the ceiling fan, in the electronics equipment, that unit is not in the farad. Their unit is in the nanofarad, picofarad, like this. So general term is a farad. So likewise, we have some terms. Okay. Especially in the machines. In the machines, we are using the term magnetic field. So in the magnetic field, mostly we remember the unit Weber. In our college life, we use the term Weber. Rarely we familiar with the word Tesla, but mostly we know the word Weber or Weber per meter square. This is the term we are using in the college. So the unit for the magnetic field density, it is Tesla or Weber per meter square. Both the sums are same. 1 Weber, 1 Tesla, which is equal to 1 Weber per meter square. 1 Tesla, which is equal to 1 Weber per meter square. Let me discuss these. These are the terms frequent. Yes, tell me, sir. This term we are frequently used in the electrical machines topic.
Interesting.
So 1 Tesla, 1 Weber per meter square, Weber this. There is no need to. During the problems, we can recollect that things.
Okay.
And another important thing, just remember these terms because we are familiar with these terms only. Micro, milli, kilo, mega. We are familiar with these terms. But in problems, they mention that picofarad. But we solve the problem by using SI units. So that's why we must know the prefix factors. Because they ask the question, for example, so voltage 10 volt, resistance 100 ohm, current I is equal to V by R. We know the formula, let me discuss later. So answer is 10 by 1000, which is equal to 1 by 100, which is equal to 0.01 amps. Okay, but in the question paper, they didn't, the options is not like this. A is equal to 0.01. Their answer is 1 milliamps, 1 microamps. Likewise, they give the options. So at that time, we must convert these numbers into this prefix factor. So because we did a mistake in the exam. So just having an idea about this prefix table and having a practice in the system calculator.
Sir, question.
Yes, sir, tell me, sir.
Sir, this one, 0.01. So it means 10 ki power minus 2.
Yes.
10 ki power minus 2 is called pico, nano, what is called? 10 ki power minus 2.
We convert the 10 power minus 2 into 10 power minus 3. By this way, we can able to get the milliamps. Let me have a problem in the next slides. So our answer is 10 power minus 2. Okay. We have the answer 10 to the power minus 2. But in the 10 power minus 2, there is no numbers here. So we convert the 10 power minus 2 into 10 power minus 3. So by this way, we can able to say it is we convert in the milliamps.
Okay, so 10 ki power minus 2 and 10 ki power minus 3 is equivalent.
What is the value?
Should be equivalent or?
No, it's not equivalent. Let me have a one by one I will come. So that's because here what is the importance for the to remember the prefix factor. That's why I give you some example. Okay.
Clear. Done.
Yes.
Copy.
The importance of the prefix factor is too important. That's why I give this example. Let me solve the problems. In what way we can be able to convert this answer into the prefix. So the electrical we start from the Ohm's law. So Ohm's law, in simply we say that I is directly proportional to applied voltage. So read the sentence, first sentence, at constant temperature.
Okay.
So it is the word too important. So Ohm's law is applicable for the constant temperature. If the temperature varies, the Ohm's law is not applicable. So Ohm's law is applicable for the constant temperature. Sometimes we say the room temperature. But in general, the most apt word is the constant temperature. So Ohm's law is applicable for the constant temperature. Number one. Number two, the current flow in the circuit is directly proportional to the applied voltage. Now I have one doubt. Y is directly proportional to X and X is directly proportional to Y. It is equal or both these equations are equal or very different? We have two equations. Equation number one, Y is directly proportional to X. And second equation is X is directly proportional to Y. Both
Should
the
be
equations
Equal. Is equal. Both is equal.
okay, but so mathematically it is equal. But from Ohm's law, the current flow in the circuit is directly proportional to the applied voltage. So see here, so imagine that we have a circular tube. In the tube we have a ball. Each circle we call as a ball. That is electrons. So the movement of electrons we call as a current. Okay. This tube we call as a conductor. Then we have a numerous balls are there. Each ball we consider as a electrons. This flow of electrons we call as a current. To flow, I need give some pressure. If I give some pressure, the electrons will move. So who is the cause? Because in mathematically, this is x-axis, this is y-axis. So x-axis, we have a pressure, voltage, because after giving the pressure, the current will move. The ball is moved. So in the x-axis, we have a pressure. In the y-axis, we have a movement. That means in the x-axis, we have a voltage. In the y-axis, we have a current. So come to the point. This is voltage. This is current. Here current, here voltage. So mathematically, I is directly proportional to V and V is directly proportional to I. It is equal. Mathematically it's equal. But due to this concept, as per Ohm's law, this equation is correct. It is wrong. If you increase the voltage, the current will be increased. So, okay, are you got the point?
Yes, I got it.
So, because
Yes, correct.
why I explained that in the exam, they from Ohm's law, there is a different type of questions they may ask. Question number one. In general, they ask the question number one. The Ohm's law is applicable. Number one, at constant temperature, at variable temperature, at 0 degree Celsius, whatever we have it. So we have options one. So the answer is constant temperature. Okay. Number two, from this statement, from this statement, they have options A. So we have a 4 options are there: A, B, C, D. We have 4 options. So
Okay.
which graph is applicable for the Ohm's law?
A.
A.
A. Because compare the A and B. Both the equations we have in the x-axis we have voltage, but see the A, we start from the origin. If no voltage, if there is we have no pressure, it is not move. Okay. Here, see here, without any voltage, there is a current present here. It is not possible. So the answer is A. So here in the x-axis we have the current, so it's ruled out. It is ruled out. Here they start from some value, so it is ruled out. This is the right answer. Okay. So Ohm's law, we have a resistance, unit is Ohm, we represent a symbol. These are the not important. So in general, the insulator resistance in terms of mega ohm, and general we have a different units are there. David. So from Ohm's law, we have a question based on the concept and based on the formula. So now we have a sample 2 questions based on the concepts. So based on these problems related to the concept as well as the application of the equations. So read the question. You are measuring the current in a circuit that is operated on an 18-volt battery. The ammeter reads 40 milliamps. Later, notice that the current has dropped to 20 milliamps.
Answer is 9.
Answer is 9. Because current I is directly proportional to voltage. So initially we applied 18 voltage, we have the 40 milliamps. We apply, first we apply 18 voltage, we get 40 milliamps. Then we see, due to some reasons, we see the ammeter, it is a 20 milliamps. So here that is definitely the voltage is less reduced, because from Ohm's law, I is directly proportional to V. If V increase, I increase. If I decrease means default voltage also decrease. So the answer is less than the 18 voltage. So how much? It is directly proportional. So this is half of this value. So here half of this value. Okay. So resistance R is connected at, so we have explanations.
Okay.
So now we have a So we have electrons. Here we give the pressure. That is, we apply the voltage. We apply the voltage. So the electrons move. That is current. Okay. From Ohm's law, the flow of current is directly proportional to the voltage. Now we have another parameters also is here. Depends upon the floor. For example, we are just imagine that the floor. If the floor is a concrete floor, marble, tiles, so we have a different, depends upon the frictions, the movement is vary. So we have, apart from this voltage, we have other parameters also involved to flow of the current is involved, depends upon these things. That is, these things are length, cross-sectional area, nature, temperature. These four things are important to depend the flow of current. So that is the flow of current. So here, irrespective of the discuss about the current, we call as a resistance. So the resistance is depends upon the length, cross-sectional area, nature of the material, and temperature. Imagine that it is a constant. If we forget this, the last term, we have a three parameters are there. These three parameters we call as a R is directly proportional to L by A. This is the equation. Resistance, which is equal to R is equal to rho into length divided by area. The rho stands for the temperature, the nature of the material. So it's directly proportional. Suppose if you walk in that snow, we are moving fast, too fast. If you are walking in that mud road, it is little bit, the flow may be controlled. So it depends upon the material, the flow is changed. So that's why we call as a directly proportional. So resistance, we have a formula R is equal to rho into L by A. Rho stands for resistivity, L stands for length of the conductor, A stands for area of the cross-sectional material. So length, it is the length. What is the unit for the length? In the SI unit, meter. So area is maybe as the area, unit for the area is a meter square, but depends upon the problem. It is, we must carefully read whether it is a circular conductor or square conductor. So depends upon the given problem, the formula may be varied. If it is a circular conductor, we are using the formula pi r square. If it is square, we are using A into A. So let me. So it is meter square. And rho. So rho, we had a resistivity, but now we didn't know the formula. We forgot the formula, but we know the unit for the resistance is ohm. So we know the formula, unit for the resistance is ohm. That is ohm, which is equal to rho into meter divided by meter square, which is equal to rho by meter, because here meter, so meter square cancel, we have 1 by m into mho. So multiply this value, rho is equal to mho meter. So this is the formula, unit for the resistivity. This question is asked in the UPDA exam. What is the unit for the resistivity? What is the unit for the resistivity? Ohm meter. So now we discuss the resistance, resistivity. Resistance, resistivity. The reciprocal of the resistance we call as the conductance. Okay.
Okay.
Reciprocal of the resistivity we call as a conductivity. This unit is ohm. In our college life we studied this unit is for the conductance, we call as your mho. We call as your ohm. Here we call as your mho, MHO. By this way, or G. Here unit is ohm. Here unit is mho. Here unit is ohm meter. And similarly, this is also they asked in that exam, UPDA exam, what is the unit for the conductance? Either mho or Siemens. So we have a unit Siemens or mho. But in the exam, they ask this question, conductance, unit for the conductance is resistance, resistivity, whatever we have, the unit is Siemens. So these questions also they ask frequently asked in the exam.
It's the same, right? Siemens, Mo, is it same? Both of them same? The
Both
unit?
are same.
Okay,
Both are
okay,
same.
okay,
Siemens or mho.
okay. What about for the conductivity? Conductivity, what is the unit?
Conductivity mho for meter, ohm meter. Here.
Okay, ohm meter before. For resistivity, ohm meter. Here, Mo meter. Okay, okay,
Mho
okay.
per meter divided
Mo
by.
per meter.
Here
Okay,
is a divider.
okay, right. Yeah.
So now we have a sample problem based on the resistivity unit formula. So a wire having a resistivity 1.6 into 10 to the power of minus 8 ohm meter. Length 20 meter.
Okay.
Cross sectional area 1 millimeter square. 1 millimeter square. Carry a current of 5 amps. Determine the voltage drop between these two wires. So read the question here. We need to find the voltage. Our objective is to find the voltage V. V which is equal to, from Ohm's law, V is equal to I into R. From Ohm's law, voltage V which is equal to I into R. Read the question. Here they give the value for the current I. So the unknown thing is resistance. We need to find the resistance value. Just a minute. சொல்லுங்க பாய். ஆமாம் பாய். நான் ஒரு சாரோட மீட்டிங் இருந்ததுனால இது பண்ணல. நாளைக்கு காலை அனுப்பிக்கிறேன் நான். So to find the voltage, we need the current and resistance. The current is the given data. Unknown value is resistance. They didn't give the resistance, but they give the other values. So R is equal to rho into L divided by A. Rho 1.6 into 10 power of minus 8 into length. Length is 20 meter divided by area is 1.
Okay. 1.
But read carefully. What is the unit for the area?
Millimeter square.
The given data, they give the millimeter square. But general formula, the unit for the area is a meter square.
Meter square.
Here they give that unit ohm meter is correct. Here they give the meter. It is also correct. But they give that millimeter. So we must convert this millimeter into meter.
Meter. Okay.
So 1 meter, which is equal to 1000 millimeter. Okay.
Okay. Fine.
So that's why 1 millimeter, which is equal to 1 mm into 1 mm, like this. Because we engineers, but we didn't use these terms. So that's why I give the symbol. So 1 meter is equal to 1000 mm, but they given in that. So 1 mm, which is equal to 1 by 1000 meter, which is equal to 10 to the power of minus 3 meter. Okay. So that's why we substitute this 1 mm into 1.6 into 10 power minus 8 into 20 divided by 1 mm. We can be instead of 1 mm, we put 10 to the power of minus 3 meter into another 1 mm 10 to the power of minus 3 meter. So meter into meter gives the meter square. So 10 power minus 3 into 10 power minus 3 gives 10 power minus 6. So here we know the formula. We know the formula. But where we did the mistake? Here.
Here, meter.
Okay.
Okay, fine.
So now we find the resistance. Then simply substitute this value, we get the voltage. Okay. And once again, in the last class also I insist, once again, use these terms. It is easy. Whether you are using in the calculator, we can able to get the answer easy. But try to use these equations in the system calculator. Because in the system calculator, we find where the 10, how to put the 10, how to put the minus, how to put the rise, 10 to the power minus 8. So in the calculator, we have a 10 power of minus x. In the normal calculator, we have a 10 power x. We can be able to put that 10 plus the 10 power of x and we get the answers. But in the system calculator, we need to have a practice. So inshallah, within the 2 or 3 days, we have an online regular classes. At that time, we are using the systems. So I will explain how to use this system calculator. Next. So these questions is asked in the UPDA exam. A wire of 2 meter. Read the question. A wire 2 meter length. So another wire we have a 5 meter length.
1 meter length and made up of
same material. So assume that here we have a wire 1, wire 2.
Yes.
What are the parameters are there? Length, area,
Area.
flow.
Area passing, air resistance.
Here we have a same material.
Same material.
So that is same. Having a same area.
Okay.
Same. For example, say for example, if it's 10, it is also 10. Suppose it is 5, here also 5.
Okay.
But length is for wire 1, it is 2 meter. Wire 2 is 5 meter. Okay. Now, what is the question? Which wire has a higher resistance? What is the formula? R is equal to rho L
by A.
A. For the resistance, for the wire 1, what is the formula? R1, rho 1, L1, A1. For resistance, wire 2, resistance 2, which is equal to rho 2, L2, area 2. Here, both the wire have the same resistance. So, we forgot about this value. Both the resistance have the same material. We forgot about this value. That is, R1 is directly proportional to L and R2 is directly proportional to length 2, length 1. So, here 2, here 5. That means wire 1 having a resistance of 2 ohm, wire 2 have a resistance of 5 ohm.
5 ohm. Okay.
So that's why 5 meter wire having a higher resistance, because resistance is directly proportional to the length.
Okay.
So in general, they ask the question like this. So these are the questions, concept oriented questions. So in general, in the first DC fundamentals and AC fundamentals, mostly they ask the questions based on the concept, based on the problems. So it's two important things, especially for the session 1 and session 2. So it's a little bit a lengthy one that we discuss carefully. So here read the question. A lead wire, iron wire, connected in parallel.
Okay.
The respective specific resistance are in the ratio 49 and 24.
24. Okay.
That is, specific resistance means the another word for the resistivity.
Okay.
Another word for resistivity is called specific resistance.
Okay.
Resistivity and specific resistance, both are same. Okay. So specific resistance mention that resistivity. The former carries 80% more current. So first what are the given terms? Resistivity, then current, the former carries 80% more current than the later. The later is 47% longer than the former. So longer, so they mention the length.
Okay.
Determine the ratio of the cross-sectional area. They ask the area. Here they counted in the parallel. Okay. Now, so two wires. Assume that it is a wire 1. Lead wire. And here we have another wire. iron.
Iron.
So both the wires are connected in parallel. Here the lead wire I represent as 1. The iron I represent as 2. So this wire, lead by this material is made up of lead. So that's why I put it is a resistance 1, and this metal because R2. That is the lead wire having some resistance value. So that's why I put a R. Both this wire also we have a resistance. I put R. So differentiate these two things. I put a suffix 1 and 2. So R1 stands for resistance of the lead wire. R2 stands for resistance of the iron wire. Then the specific resistivity of specific resistivity are in the ratio 49:24.
24. Okay.
That is here resistivity. What is the resistivity for the lead wire? Rho 1.
Rho 1.
Resistivity for the iron wire is Rho 2.
Rho 2.
Their specific resistivity, that is Rho 1 ratio Rho 2,
Rho 2
is equal to 49 ratio 24. Or in other words, we say Rho 1 divided by Rho 2 is equal to 49
by 24.
24. Okay?
Okay.
Then the former carry 80% more current than the later. So here they mentioned the term current. So first resistance lead wire carry the current I1. Iron wire carry the current I2.
Okay.
Okay.
Sure.
Here the word former carry 80% more than the later. Here they mention the two terms, iron and the lead and iron. Which is the former? Lead wire is the former. Which is the later? Iron wire is the later. So this I1 carries this I1, that is former means I1. This I1 carries 80% more. Suppose assume that former and later carry equal current, means I1 is equal to I2. Former carries equal current in the later, that means I1 is equal to I2. Here they mention 80% more, that means 1.8. Or you understand? Here they mention 80% more.
Okay.
So that's why that is 180%. It's the first lead wire carries the current.
Sir, 1.8, how can?
Yes, that's me. I1, I2. Suppose the former carries equal current.
Okay.
Carry equal current. That means I1 is equal to I2. Okay. Now, but here the former carries 80% more current. Suppose this iron carries 100 amps. How much it carries?
More than 80%.
More than
180.
80%. 180.
180.
Okay. That means 1.8 times. I2 is equal to I2, assume that I2 is equal to 100 amps. I1 is equal to 80% more than
Then
I2. That is 100 amps plus 80% of the 100 amps, which gives 180 amps. Suppose it is 1 amps. If it is 1 amps means it is 1.8 amps. So that's why I write I1 is equal to 1.8 I2. Okay?
Okay.
So on another next one, the later is 47% longer than the former. So later means here the word longer. So that is length. Here they mention the later. Later is the iron. Iron is 2. Lead is 1. The later is 47% longer. That is 1.47. Okay?
Okay.
So now, from this statement, from this, row 1 divided by row 2 is equal to 49 by 47, so 24.
20.
From this this line, we get I1 divided by I2 is equal to 1.8. Okay? Because we have I1 is equal to 1.8 I2. So that's why I1 divided by I2 which is equal to 1.8.
Okay.
From this L2 divided by L1 is equal to 1.47. Okay?
Okay.
Now go to the first line. R1, that is lead wire. R1 is a lead wire. R2 is a iron wire. Both are connected in parallel. Okay? Suppose if we apply the B voltage. Okay? If we apply the B voltage, what is the current flow here? From Ohm's law?
V current flows there. V by R1. V by R1.
Okay. From Ohm's law, I1 which is equal to V1 by R1. But in the parallel circuit, voltage same. So that's why I is equal to V by R1.
R1.
Similarly, here I2 which is equal to V by
R2.
R2. Okay.
Okay.
Now, just I1 which is equal to V by R1, I2 is equal to V by R2. What is the ratio of I1 which is equal to V by R1 ratio V by R2? Correct? It's correct?
Yes, sir. Equal to
Correct.
VBR. Correct.
Okay. That is I1 by I2 is equal to V by R1 by V by R2.
VBR2.
Okay. That is I1 by I2 V by R1 V by R2, which is equal to V by R1 into R2 by V. So cancel this. Ratio of the I1 by I2 is equal to R2 by
R1.
R1. Okay.
Okay.
Now I1 by I2 is equal to
R2 by
R1
R1.
by, correct? R1 by R2.
R2 by
R2
R1.
upon I,
Yes.
R2 upon
R2 by
R1.
R2 by
R2
R1.
by R2 by R1. The resistance in terms of resistivity, length and area. What is the formula? R2 we can able to write R2 which is equal to rho 2
So
L2
L2
by
by
A2
A2.
divided by rho 1
A1
L1
by A1.